Hello students, today we are going to solve some questions on the topic linear algebra and matrices from the mains question paper of Uttarakhand ESO examination 2018. First question is, let A, B, C and D be the n by n matrices each with non-zero determinant. If A, B, C, D equals to I, then B inverse will be, the answer will be C, D, A. You can easily verify it as A, B, C, D inverse will also be equals to I, and then this inverse will be equals to D inverse, C inverse, B inverse and A inverse equals to I, and then multiply this D here, it will be D, it will become I, and so on. Try to remove all these C inverse and A inverse, you will left with C, D, A. Next question is, the sum of the eigenvalues of the square matrices. In any square matrix, the sum of eigenvalues is the trace of that matrix. So the correct answer is option number 3. Next question is, the coordinate vector v equals to 3, 5, minus 2 relative to bases 1, 1, 1 and 0, 2, 3 and 0, 2, minus 1 will be. In this type of a question, what you have to do is you have to write down the linear combination for this vector, means this 3, 5, minus 2 can be written as A E1 plus B E2 plus C E3. And then what we have to do is we have to find out the value of A, B and C, and this will be our required answer. If we put 1, 1, 1 in place of E1 and 0, 2, 3 in place of E2 and 0, 2, minus 1 in place of this E3, you will have, and then finally compare with this left hand side, you will have A equals to 3A plus 2B plus 2C equals to 5 and A plus 3B minus C equals to minus 2. When we solve these two equations, you will have A equals to 3, B equals to minus 1 and C equals to 2. So the correct answer is option number 2. Next question is, the dimension of this over this q root 2 will be equals to 4. We have already proven this question in our earlier videos. You can check it out there. Next question is, two vectors AB and CD in R2R are linearly dependent if the value of AD minus BC. Simply try to put AB, CD in matrix form and then calculate the determinant of these vectors. For linear dependency, the determinant should be equals to 0. That means if we calculate this determinant, we have AD minus BC will be equals to 0. That means our correct answer is 0. Next question is, if A and B are two n by n matrices such that A plus B equals to I and AB equals to 0, then in such type of a question, simply evaluate this and then replace this and this. If any matrix to be idempotent, we must have A square equals to A. If by substituting these A square equals to A and B square equals to B, if you are verifying the equation, then that means the equation will be idempotent. You can easily verify that A and B both are idempotent if A plus B equals to I and AB equals to 0. Let A equals to 0, 0, A 0. This is our given matrix where A is not equals to 0. If B is a 2 by 2 matrix which commutes with A, then the eigenvalues of B are. I am leaving this question to you and with the hints that first calculate the value of eigenvalues for this A, and then this condition, the commutes means if A and B are two matrix which commutes, that simply means we have AB equals to BA. With these two, simply calculate the eigenvalues of B. You will have the answer. Next question is, if a 3 by 3 matrix A has the eigenvalues 1, 2, minus 1, then the trace of the matrix. Trace of the matrix means you have to calculate the sum of the eigenvalues. Now, for calculating the eigenvalues of the A inverse, what we have to do is we know that if lambda is the eigenvalue of A, then 1 upon lambda will be the eigenvalue of A inverse. Means the eigenvalues will be 1 upon 1, 1 upon 2, minus 1 upon 1. That means 1, 1 upon 2 and minus 1. And for this A square, the eigenvalues will be 1 square, 2 square and minus 1 square. That means 1, 4, 1. The trace of the matrix B will be 1 plus 1 by 2 minus 1 plus 1 plus 4 plus 1. It will come out as 13 by 2. So the correct answer is option number 1. Next question is, the system of equation is given. It has a unique solution if, as we know that in any system of equation, unique solution exists only if we have rank of this matrix A is equals to rank of matrix C is equals to number of unknown variables. If we have two matrices A, this represent this system of equation, and this C is augmented matrix, then if rank of A equals to rank of C is equals to number of unknowns, then we will have the unique solution. Okay, that means first we have to convert this equation into augmented matrix. That means it will be 1 1 1 1 1 3 2 2 and 3 minus 4 k and 4. When we reduce this augmented matrix, we will have 1 1 1 1 0 0 1 by 2 and 1 by 2. Here we will have 0 0 k minus half, and here 9 by 2. This is our matrix. As we know that for unique solution, rank of this matrix should be equals to number of unknowns. As we know that number of unknowns are 3. If this will become 0, if this first thing will become 0, then the rank of this matrix A will be equals to 2. That's why we can't have any unique solution. Means we can't afford to have this k minus 2 as a 0 value. That's why the unique solution will exist only if k is not equals to 1 by 2. Our last question is, which one of the following is not a subspace of R2R? As we know that the necessary and sufficient condition for a non-empty subset W of a vector space VF to be a vector subspace is that if alpha, beta belongs to W and this A, B are in F, then A alpha plus B beta should belongs to W. And we have proven this problem in detail in our previous video. I will put the link in the description bar. You can check it out in detail. Simply let you have two elements alpha equals to x comma x plus 1 and beta as y comma y plus 1. And we have two elements a, b from this belongs to R. Then simply prove A alpha plus B beta does not belongs to this R square it will solve our problem. It will give us which one of the following is not a subspace of R2R, and you can easily check it out that this x comma x plus 1 is not a subspace of R2R.